Hello and welcome to today's ACS Agro webinar. My name is Paul Ryback from Smithers Viciant, and I will be moderating today's session. And I have the pleasure of introducing Dr. Michelle Embry. Dr. Embry received her Ph.D. in toxicology and a BS in biology and environmental science from Duke University. She is currently Associate Director of Environmental Science at the Health and Environmental Sciences Institute, HESI, who is helping to support this webinar. Prior to joining HESI, she was an ecological risk assessor at the US EPA Office of Pesticide Programs. She has extensive experience in both human health and ecotoxicology, and has an emphasis on integrated approaches and alternative methods for risk assessment. Her current project portfolio includes projects related to ecological and human risk assessment, and she is the manager of the risk assessment in 21st century RISK21, which is what she will be talking about today. She is a member of CTAC, the International Society of Exposure Scientists, and the Society of Toxicology. If you would like to submit questions, please fill in the question box, and we will take those questions and answer them at the end of the webinar. So it's now my pleasure to introduce Michelle, and hope you enjoy the webinar.
Great, thank you, Paul, and thanks for having me on this webinar. I appreciate the invitation to speak about this project. What I'll be talking about today is an overview of this sort of long-term effort that's been going on for quite some years. Several of you have likely heard versions of this presentation, although the attendees list, there are quite a few folks who I am not familiar with, so welcome, and I hope that you find this informative. But this is really kind of giving an overview of the project. We have a lot more ongoing work that's happening within my organization. And if you're interested in learning more about that, please let me know. But for the purposes of the webinar today, I wanted to really just provide an overview of the framework that was developed and a few of the applications which go into much more detail on the publications that are available. So just to give a little bit of an introduction, and I think some of this should be very familiar to many of you, largely sparked, not only, but largely sparked by a series of National Academy of Sciences reports. There's really been what some people are calling a bit of a paradigm shift in risk assessment. And the tox testing in the 21st century report that came out really kind of helped to feed this fire as far as calling for a shift. And then there were follow-up reports looking at exposure science and decisions. And the most recent is looking at using these 21st century science approaches to improve risk assessment in general. But Tox 21 was really the first one of these reports that really pushed things to move in risk assessment and integrate new methodologies and look at in vitro testing and high throughput and other types of approaches. One of the things that, and this is all great, but one of the things that is led to, and this is sort of a blanket statement, was this concept of we can do more. So we have new regulations, we have new pressures, we have new chemicals, we have more chemicals, we have mixtures to address, you could add to the list. So the call to really do more, and then with more, so we have new methods and new models and new technologies and approaches, which is all great, but we're also asked to do this all with less. So we have less resources, less animals. I'm sure you could add to that list as well. So the question is, how can we integrate all of the great thoughts that came out in these reports and in new science to shift risk assessment with all of these constraints that we're aware of? So the HESI RISK21 project is not new. It was started in 2010, which I sometimes can't believe. And the mission is up at the top to really try to look at how we can improve reliability. We can really keep this idea of resource appropriate, so identifying the fact that we don't have unlimited resources, and make sure that we can bring in applicable approaches to the world of, and I have in parentheses, human health risk assessment. This was really originally developed in the human health risk assessment sphere, but there's been a lot of work ongoing to try to move it and look at ecological risk assessment as well. So the way HESI operates, we're a nonprofit based in Washington, D.C., and our aim is to really bring together global scientists and regulatory people from academia, industry, government, and NGOs when we can get them involved as well, so other stakeholders, to address issues related to human and environmental health concerns. And so this group, when it was really rolling, involved over 120 people from the various sectors working on projects. So what I'm presenting here is the end product, so to speak, of what we developed, but there were multiple sub-teams working on this throughout the life of this project, and it's ongoing in sort of a phase 2 as of now. So through this, we developed a risk assessment approach that was really aimed at embracing the advances in the new methods and what was out there, but also revise our current thinking for how to approach it. And the principles are listed here, and this sort of came out at the end, and you'll hear me talk about this quite a bit throughout the presentation. Problem formulation based. So before you embark on the risk assessment, before you start collecting your data, what is the problem you're trying to address? We also embrace this principle of exposure-led, and that's largely based on the fact that in many risk assessments, gathering hazard information is the first step, and exposure generally was sort of added on at the end. And so to balance that out, we really wanted to make it risk-based at every step, but felt that we really needed to focus on exposure as a first step, at least initially. We also wanted to make sure that we utilize existing information, so it's not throwing out all of the information we know just because we have something shiny and new. It's leveraging what we have. We also needed something to be flexible so that it could be very fit for purpose and could also address various issues. Of course, transparency is very key. We made something that we think is very helpful because it is visual, and you'll see that in a minute. The fit for purpose is extremely important, and that kind of gets to the definition of the problem you're trying to address. And then we have this principle, and this will come up in another slide, but the idea of, do you have enough precision to make your decision? You might be able to use screening level approaches and get at the decision that you need to make, or you might need to do a full-blown, very detailed assessment looking at biomonitoring information and very detailed toxicology information. It really depends on that problem formulation. So we like that little catchphrase, and you'll hear that several times throughout my talk. So how is this different? And I know that we're in the agro division of ACS, so many of you are probably familiar, at least in the US, with the 40 CFR or the data requirements for pesticide registration. So the current paradigm is you really start with this data generation phase and generally might follow certain requirements like OECD test guidelines. So that information is collected, and then you move towards the problem formulation, develop a conceptual model, and then select and apply the relevant data from that large data generation piece that started up front, and then do your risk evaluation. The new paradigm we're looking at, as I talked about on the last slide, starts with problem formulation, move towards that development of the model, and then the data generation happens in a more targeted way based on the problem formulation and the conceptual model. And then you move through applying the relevant data and the risk evaluation, and that dotted arrow just indicates that you could always, based on that question of do you have enough precision to make your decision, could go back and generate additional information to refine that assessment at any stage of the process. So what I'm going to be talking about and diving into is all published, and these are the papers since the first came out in 2014 and the last year. They really walk through a lot more detail than what I'll be able to get into on the webinar today. There's also, I will be talking about these two case studies in a little bit of a high-level view, but more details are in these two publications. And then over here on the right, the most recent paper is really talking about the approach for exposure assessment, and that's something that I would point you to. I'm not going to get into a lot of detail there. And then there's two other papers on how this approach might be applied in the cumulative risk assessment sphere, so I would just point you to those. They're all open access and available at RISK21.org, which is the website for the project. So this is what the general framework looks like. and we'll get into the details as we go through the subsequent slides, but just briefly, our little red circles here identify the starting points and the process through which you walk through. The first step is problem formulation, so identify what you're trying to address, what information you have, what information that you need, and of course, what is the risk context that you're operating under. And then we have as step 2, looking at exposure. And what we have are these inverted triangles, which really identify the level of information, level of refinement, and also resources needed. So as you move up and you get to monitoring information, it's more refined information, but it also necessitates increased use of resources. So the inverted triangles are representing that for both exposure and toxicity. So you would move through, and based on the problem formulation and based on the information available to you, would identify what information you have to get an exposure estimate, and then the same in the toxicity realm as well. So you move through these various tiers. And then the next step, step 4, is to really evaluate your risk. And what we have here is this matrix that allows you to integrate exposure, which is shown on the x-axis, and hazard on the y-axis, to get a picture of risk at every step of the process. And I'll go through this in more detail. And then, of course, depending on whether you have enough precision to make your decision, you could either conclude your assessment or refine it by getting higher tiers of information, potentially refining your problem formulation and going from there. So that matrix is something that if other people come and talk to me about RISK21, it seems to be the thing that they always sort of focus in on, which is great. It's not the only part of the framework, and I want to stress that here. But this is sort of, I think, what maybe is a bit more novel and what came out in the project. But it's important to note that this isn't the only piece of it. The other parts of the framework are important. So what we have on this little grid here is the exposure on the x-axis, and one of the most important things to note is you have to have units that are like for like. So if your exposure estimate is in milligrams per kilogram per day, your toxicity estimate has to be with the same units, parts per million, et cetera. So you have a log scale on the axis here going from low exposure to high exposure. And on toxicity, same idea. It's an inverted axis because the higher the number is the lower toxicity. And the shading happens from green to yellow to red, meaning low exposure, low hazard, high exposure, high hazard. And the yellow is what essentially is your margin of exposure, or that ratio. And right now, the default setting for this is at 1:1. So that's where the yellow zone is shown. So what you can do then is you can plot your range of toxicity values and your range of exposure values, and you get a box, which is essentially your visual representation of risk. Yep, go back here. And so what you can see here is this gives you an idea of the relative range of uncertainty in your tox estimate and your exposure estimate. And the positioning of this box gives you an idea of your picture of your risk based on where you would draw your acceptable margin of exposure, which is, of course, that decision that needs to be made when you talk about your problem formulation. What is the risk assessment look like? What margin of exposure do I need to be above or below, for example? So your starting point is problem formulation, which sets out the objectives, the scope, and the hypothesis that you're looking at, and really is getting at what do you know, what do you need to know, and also what do you know, and how do you know when you're done? So do you have to be below a margin of exposure? Is it 1 to 100? Is it 1 to 10? Is it 1 to 1, et cetera? And enough precision to make the decision pops in there again. So the framework from problem formulation, and some of the folks working on RISK21 from Syngenta, and there's a recent paper that just was accepted for publication on this, on problem formulation framework, has laid this out. And it's not just one piece. It's sort of framing the problem, exploring the problem, mapping out how you're going to address the problem, and then sort of working through this process. So framing the problem, and I can't overstate how important this piece is on this. Clarify and then get agreement on what the question is that you're asking. Develop your fully formed problem statements, and then identify what the boundaries are of that. And generally, of course, with anything, do we have agreement that we're all moving in the same direction? Exploring the problem moves it more towards that operational state where you develop a conceptual model to trace, say, your chemical contaminant through the exposure pathways and then through to the target of interest, for example, and then consider and prioritize where you might go with your resources, how you might act on this. And then, of course, identifying what information do you have? Do you have any knowledge gaps? And the conceptual model can help with that. So this is just a hypothetical conceptual model for, in this case, it's a pesticide where you would have probably more specifics on the use pattern, the methods of application, identify the different ways, the exposure pathways. You could, in this case, have an indoor spray. You could have bed nets dipped in it. And then your exposure pathways here, inhalation, dermal, oral. You might have this case over here where you have misuse of that pesticide, where you might wash the bed net, or you might mouth on the bed net, and we'll get to that in a little bit with an example. The various media, so you have surface water, drinking water here, and then the receptors. So you can look at human exposure through non-dietary or through just direct consumer exposure, or you could have potential exposure to aquatic organisms, for example. So this is just sort of tracing out what your problem is and gives you an idea of the map that you would need to follow. So that's the problem formulation step. And then step 2 is exposure. And this is pretty straightforward. You're looking at what is the source, what is the media through which I might be exposed, the frequency, the magnitude, the route. That's really kind of what we're talking about here. And this is that inverted triangle I was telling you about with just a little bit more detail. So as I mentioned, you have increasing resources and level of refinement as you move up into the thicker part of the triangle. And what you have here is the different, just sort of generalizations of a tier 0 assessment for exposure might just rely on minimal information like phys-chem properties, for example, or use knowledge. So what can you use to get kind of a quick estimate of exposure? And this might be something extremely useful in the case of prioritization, for example. Then you move up and you have tier 1 models, deterministic types of models that integrate things like the population, the exposure route, the fate, volume of release, maybe some more specific use information. Moving up to probabilistic models usually require much more detailed use information or maybe some specific relevant measurements. And then, of course, monitoring information could be biomonitoring, could be media monitoring, et cetera, et cetera. The important thing to note with this, when you go back to that map, is that if you have an exposure estimate, you have to make sure that you're able to either translate that into units that would match what you have from your hazard assessment or vice versa. So it's just something important to note. The exposure paper that I mentioned, goes into much more detail about some examples of the various models and approaches that you might use at each of these tiers. And this also, I think, highlights some of the work that was in this more recent National Academy of Sciences report. And this really kind of looks at this concept of an aggregate exposure pathway here, which is meant to kind of mirror in the toxicology side, the adverse outcome pathway, where you're looking at the source and tracing that through to your target exposure here. And I think this just maps out not only kind of the different compartments we're talking about here that are going to be important in the assessment, but also the different methods that you can use and how they lay out. So this is, I would point you to this report, and specifically the exposure chapter gives a lot of really good information that is very helpful. So that's exposure. And on the tox side, same idea here is you have a lower tier where you might be able to use structure-activity relationships, or a concept called the threshold of toxicological concern, which I'll get to in a minute. Lower tier approaches that can help you with things like prioritization, for example. And then as you move up, you might use in vitro assays, in vitro information with in vitro, in vivo extrapolation to get a handle on hazard assessment, or you maybe would even go up all the way to a very, very detailed, very specific mode of action analysis. So this is then, you have your exposure, you have your hazard, and you would bring those two pieces together and utilize this matrix to get a visualization of your risk. So this is just hypothetical, a bunch of different chemicals and examples with, I just have arbitrarily here the margin of exposure set at 1 to 1. So this is looking at where your exposure and your hazard would be equal. If you cross that line, you're above that. So for example D, what you can very easily see here is that gathering more hazard information, more toxicity data, isn't going to be very useful in further refining my risk assessment. The exposure in this length of this box along the x-axis indicates that you potentially need more refined exposure information. So again, very visual, very easy to see what's going on. Chemical B actually has a relatively small range on the exposure side, but there seems to be some either discrepancies or high level of uncertainty factors applied to the data that maybe point towards collecting additional refined information on the toxicity side might be most useful. So that's something kind of when these fall in the yellow zone that might be helpful. For chemical E, you have relatively high exposure and relatively high hazard. Gathering a lot more data isn't really going to help you with that one. It's probably going to be some sort of risk mitigation effort to decrease exposure. So maybe this is something where it's a case where personal protective equipment might be most useful. And chemical A is probably one where you might say, we're pretty good here. This is enough precision to make my decision, and maybe it's not a problem. So again, it just makes it very easy to kind of see where you're going. And this is another example. So that was sort of a high level. Another thing you can do with this matrix is you can have a range of exposure information. You can plot a single tox value. So say you have a rodent NOEL value here, which is slightly below 1, and you also then apply uncertainty factors to that value. The way that this is represented on the chart is that triangle is the actual NOEL, and the shaded area is the uncertainty factor that was applied to that specific endpoint. So it's very easy to see where the toxicity value is and what uncertainty factors were applied. You can also, and you'll see this in one of my examples that I'll go through, you can plot point estimates where you just have a point estimate for exposure, a point estimate for hazard, and you see this scatter plot. And the positioning of those dots can give you an idea of where you might need to go next. And this is for a bunch of different chemicals. Another example is you might have a single chemical where the hazard is going to be what the hazard is, for example, but you want to look at different exposure scenarios. And in this case, this chemical, we have lower exposure in an outdoor area, in a rural area, and the highest exposure in indoor areas, and somewhere in the middle for urban areas. So you can kind of segment out where you might have higher risk based on exposure scenarios. And then you could also, on this plot, do all of these things together. And if you would like more information on how to use this plotting software, which is available on the tool, please email me and I'm happy to help you out. We made this into a web-based tool on risk21.org. So you're welcome to go there. It's freely available. It doesn't cache any information. So once you hit refresh, all your data can go away if you don't save it. But it's interesting to kind of play around with it and learn how to use it. So I'm not going to get into the details of that, but it's something that is freely available for you to use and see how it might help you in your work. So I'm going to quickly, and again, these are published, so happy to send you to those papers for more information, go through two applications. The first, and given that this is the agro group, I figured it would be good to go through this case study. We're calling it our pseudomethrin case study, and it's really looking at an nth in class new pyrethroid. So this is the 11th pyrethroid. You work at a company, you've made this chemical, and the question is, can it be used on bed nets to protect against mosquito bites? And again, it's not the first pyrethroid that's ever been created, but your challenge with this in the problem formulation is to determine reasonable certainty of no harm to use this in dipping bed nets, and then also the risk that you're looking at when you're talking about people that might be sleeping under the treated net. So you're looking both at the people impregnating the bed net with the chemical as well as the people using the bed net. And you're also constrained, and we tried to make this fun, that you can't use more than 50 animals. And obviously, if you were going to follow a full 40 CFR protocol, you know that that would take many, many more than 50 animals. So that was kind of the starting point. And where we began was sort of this tier 0, that lower tip of the triangle of exposure. So we looked at phys-chem properties and we saw that there's very low volatility. So we decided that inhalation was probably going to be a negligible route of exposure. And then based on the scenario that we were looking at, where you're talking about nets that have been dipped and you're sleeping under them, you have really not really acute exposure. It's more of a subchronic to chronic duration. And what we did here is sort of separated the people who are dipping the nets to those who are sleeping under the nets. I'm going to really focus on the sleeping under the net scenario here, but the dipping part is in the paper. So what we looked at is the different routes of exposure. You have dermal contact, so you're touching the net, hand to mouth, where you touch the net and then you put your hand in your mouth. Children, unfortunately, will take the net and actually chew on the net. And so those are the different exposure pathways. And of course, we're interested in the total or aggregate exposure as well. And this is largely based on the estimates of exposure here are based on something that was published in WHO. So we're borrowing what they had already developed. So in this case here, we're looking at infants as our key population that we're worried about, and our total and aggregate exposure ranges here in red. So one thing related to pyrethroids is there's two distinct classes of them. There's type 1 and type 2, and there's also some that have mixed effects. And the effects correlate with structure. So you generally have type 1 and type 2 pyrethroids, and that will affect the toxicity of the chemical that you're evaluating. So one of the questions with this case study, of course, is when you're looking at hazard, this is something to consider when you have an nth in class, is it type 1 or type 2? So we know from the information that pseudometharin is a type 2 alpha cyano pyrethroid. And what we did here is we arrayed the available information on the other pyrethroids into a table, looking at both acute, intermediate, and long-term chronic rodent information. So the highest and lowest values for each of them are bolded. This is really sort of a read-across approach here. And what you can see is for the type 2 alpha cyano, the lambda cyhalothrin is the one with the highest toxicity values. So what we ended up doing with this is we said, okay, what we could do is bound the range of potential hazard. We just did that with exposure for this nth in class pyrethroid and see what that looks like. So that's what we did. And this is the sleeping under the net, our first assessment, where we had the exposure range, which I showed you in that previous table, from 0.01 to 0.443, which is just doing the infant aggregate sleeping scenario. And what we ended up doing for the hazard assessment is we took the most potent chronic NOEL from that table I just showed you for lambda cyhalothrin, which is 0.5. And then we applied both the default 100x uncertainty factor as well as an additional 10x uncertainty factor. So as you can see, this box kind of goes right smack in the middle of the yellow zone. We obviously need more refinement. So one of the things that we also know about pyrethroids is there's a common mechanism of toxicity. I won't go through this in a lot of detail, but really what you can be looking for is an inhibition of activity on these voltage-gated sodium channels, and the changes in this neuronal excitability is sort of an in vitro sign that you can use to predict potential in vivo clinical signs of neurotoxicity for the pyrethroids. So what we had available to us is a microelectrode array methodology where you can use mouse neuron cultures and look at inhibition of activity. So what we put down here in this bottom row is the IC50 values from that methodology. So an in vitro methodology, we still haven't done any testing here. And what we see is that pseudometharin kind of falls in between. It's not as bad, I guess, or as toxic as lambda cyhalothrin. It's obviously, I mean, we already know it's a class 2, but it's not quite as potent as the lambda cyhalothrin. So we see a 5-fold difference in the potency between our unknown, our pseudometharin, and the most potent. So if we refine this, and I haven't shown the refinement of the exposure, which actually in this case is probably more critical. The exposure range in this case was revised based on known measured dermal absorption rates in children. So that actually decreases the absorption and decreases that upper bound range of the exposure estimate. And then again, we changed the toxicity range to be from 0.5 to 2.5, and that's derived from the most potent chronic NOEL and also a 5-fold lower potency, so we could decrease and not use that additional 10x uncertainty factor. And then in the third assessment is where we moved in and we said, from the second assessment, we need a little bit more hazard information. Our exposure range is pretty tight, but our hazard range could use some refinement. So ran a single dog study, a 5-day dog study, and got a neurological NOEL of 1 milligram per kilogram per day, used the uncertainty factor, and of course integrated those in vitro screens and refined our assessment there. So that's just a representative illustration of how this approach could work, where you're really doing very targeted testing. Again, this is a scenario where you're looking at an nth class, so you already have a lot of information you can draw from, and you also know a lot of information about the chemistry. So now for something completely different, the other published case study was looking at, it's a water case study, and the general approach, we were given a group of chemicals. We had 20 chemicals that could be present in drinking water, and we were asked to prioritize which we would need to do additional evaluation of. So this was not a risk assessment. It was really looking at which chemicals we should spend resources on to get refined information. So our tier 0 in this case, sort of silly, but we just said, what do we know about the solubility of the chemicals that were on our list? So we know their names, we know their structures. Can we use that as a worst case exposure estimate and compare to the threshold of toxicological concern? And for those of you maybe not familiar with the approach, the concept behind it is you have years and years of chronic rodent NOEL data. And what the threshold of toxicological concern approach did is take that available information, look at the probability distributions of those based on a structural-based classification scheme that identifies different classes of potency. And it identifies a de minimis risk where if your exposure is below that value, you probably have very little concern. And that is probably an entirely different webinar to go through the details of that approach. But that was our tier 0. Can we utilize solubility and the TTC to screen out any of our chemicals? And actually, I'm not going to show this, but what we found is that we went from 20 chemicals to 18 chemicals. And then you can use tier 1 exposure estimates, compare them to TTC, and then refine your exposure estimates more, keep those same exposure estimates and compare them to existing information. So this is what I'm going to walk through. Just wanted to give you a little bit of a highlight of where we're going here. Prioritization approach, so very different than what we just showed with pseudomethrin. So if we start from tier 1, where we say, okay, we have 18 chemicals left, let's look at some refined exposure information. And we didn't go and run our own models, but we said, where is there some conservative, say, deterministic model information, for example, available for these 18 chemicals? So what you see there is the sources and our refined exposure estimate. So this is milligram per kilogram per day exposure estimate. And this is based on some conservative assumptions for drinking water. You drink 2 liters of water per day from the same contaminated source, and you weigh 70 kilograms, for example. And this is all in the paper. So we take the refined exposure estimates and compare them with the TTC, which is a threshold approach, and this is all in the paper as well. And it turned out that we had 9 chemicals left that we really felt like we needed to look into in a little bit more detail. Again, I'm flying through this pretty quickly in the interest of time. So where this really gets interesting, I think, is in tier 2. So we took the 9 chemicals that we had left, the 9 out of 20. So all we've done right now is taken deterministic exposure model estimates. We've taken TTC values for those particular chemical structures that we were interested in, and we screened out 11 of them. So we have 9 left. And we went and we pulled available toxicity data from various sources that are listed there, and the full sources are in the manuscript, and got chronic values, either NOELs or LOELs, for each of those chemicals, again, in the same units, milligrams per kilogram per day, and compared them with this refined exposure estimate that I showed you on the previous slide. And then we used the RISK21 scatter plot approach to sort of see what this might look like. And all of them actually fall, and again, this is just margin of exposure of 1. We're not providing any or adding in any uncertainty factors. We're just sort of seeing where they fall. And what we determined with our group is that we had 3 chemicals close enough to that 1-to-1 line that we felt like really would require another look. So again, it's not saying that they're necessarily a problem, but they would require additional refinement moving forward. So again, an illustrative example of going from 20 chemicals down to 9 chemicals, down to 3 chemicals, where it would really be most useful to focus resources. So this is kind of a summary of what we did. It's this funnel approach. Again, originally what we did, without actually even leveraging the available toxicity information, we winnowed this down from 20 to 9 by just using existing information, and then from 9 to 3 by digging a little bit more into the available database and looking at no-else and low-else. So prioritization exercise. So those are 2 different examples of the potential applications of the approach. I wanted to just sort of touch on some other things that we've done within this project that I think has been pretty important. We've done some outreach workshops, because what we learned when we first started presenting this to people is they kept saying, well, I might be able to use this in this type of assessment, or I might, how might you apply this in the case of, say, food safety, for example? So we had an initial workshop held at the FDA and the Center for Food Safety and Applied Nutrition way back in May 2015, which seems like a long time ago. That really led to some follow-up workshops where we got people in front of this tool. We came up with some hypothetical examples that people could work through, getting them to use the framework, use the approach, and in all those places all over the world there. And we've had really great success at engaging various scientists and the regulatory community, exploring how this approach could be useful. And as a result, I think we have gone back to our approach and identified what additional tools might be useful, where might we expand this to, again, help scientists and regulators do their jobs every day and use this approach. So it's something that this is ongoing. We've had a lot of really great interaction. You can see in these pictures people using the web tool, trying it out. And there have been quite a few people who've been using this either in-house, or there have been several publications of outside groups that have used this and have put it into their publications. So I would encourage anyone who wants to try this out to do that. We're really actively looking for additional people that are working on case examples, or see utility in this approach, or see utility in a modified version of this approach, for example. We'd be interested in looking at applications for different chemicals, really looking at various data sets for both exposure and hazard and how we might leverage those. And we have several applications within the RISK21 project that are ongoing or in development. So there's some additional effort, very direct effort to look at prioritization of chemicals in drinking water. So bridging from what I showed you with real world examples within a regulatory context of how prioritization can happen. And that's looking at hundreds of chemicals rather than just 20. There's been some ongoing work as a result of the outreach and workshops that we've done in Taiwan and China, looking at food contaminants. And there's a paper that came out a few years ago looking at DDT residues in tea in Taiwan. And it used the RISK21 approach. There's a lot of ongoing work. I can't get into the details, but we've been working with some regulatory agencies on some categorization and prioritization efforts in the pesticide realm. And I think that's going to be some really valuable work going forward. And if you'd like to know more information, you can send me an email. And then we're also looking at applications in different contexts. So ecological risk assessment is something that's relatively new to apply the RISK21 approach, but we've been actually asked by some groups to come and talk to members of their organization and how this might be used and what case studies would be useful in ecological risk assessment, and also even specifically with pesticide ecological risk assessment. And we're looking for people to help us out with that. Combined exposure, chemical alternatives, sustainable alternatives has been something, and there was a paper that came out a few years ago related to that concept. And then there's, of course, very specific regulatory applications that people are interested in looking at as well. So there's a lot happening ongoing within this project still, but again, we're actively looking for more ideas, examples, and partners in this. So I'm presenting this, but I am only one person of this team, and I have to thank our current Science Advisory Board and ad hoc advisors who are listed there. They are a really great, balanced, global, tripartite group of people who've worked over the last 2 years in our kind of RISK21 version 2.0 to help steer and guide where we go with this, and also the One of them was really instrumental in getting me to participate in this webinar. And our financial supporters are listed there. This is the current team, but of course, when this project started back in 2010, we had a huge group of people that were very instrumental in making all of this happen and come together so nicely. So they are, and those organizations and the kind of historical knowledge of who was involved are available on our website. And with that, I know it was a quick tour, but I wanted to leave time for questions. And as I mentioned already, you can contact me. My email is there, or my colleague Sandrine Deglin. She also works at HESI. She is working with me on the project as we move forward. So I will end there and can take questions.
So thank you very much, Michelle. That was an incredibly good seminar and very informative. We are going to take some questions. A couple of them that came up multiple times is, are you able to share the slides of the presentation?
Yes. I will send them to Kyle, and he can send them out.
Okay, good. I have a question. What's the difference between adjusting the uncertainty factor and moving the margin of exposure line from 1 to 1 to, say, 1 to 10?
Well, this comes up a lot in our training courses, and we provided both in there to have some degree of flexibility, but one of the things that we very much stress is that you don't want to have this sort of exponential confounding of uncertainty. So the margin of exposure would really kind of be equivalent to sort of what is your level of concern and your risk assessment. So you would not, for example, if you shift your margin of exposure and say it has to be 1 to 100, and then you also applied uncertainty factors on your tox data, that would sort of be a confounding thing. So there's a difference, and usually the margin of exposure is sort of a risk-based threshold that you set as a level of concern. The uncertainty factors are generally those applied, like the 10x safety factor or the 100-fold, you know, the 10 interspecies uncertainty factors. But what we do say is that you need to kind of document when you are applying various, whether it's uncertainty factors, application factors, that you document what those are and your reason for applying them. Does that answer your question? It's sort of more of a, the margin of exposure would be kind of your acceptable sort of regulatory set cutoff, for example, and the uncertainty factor is usually something directly applied to, say, a toxicity endpoint. But it's important that you don't double dip.
Is 1 to 1 used typically, or do you usually use 1 to 10 or 1 to 100, or?
It really depends. I mean, I think I'm more familiar directly with the kind of levels of concern that you see in, say, ecological risk assessment, where it would be maybe like 0.1, or it could be 1, or could be 0.5, for example. I think generally what we've done in a lot of our assessments is we leave it at 1 to 1 in, say, human health assessments, and then we use it more as a guide. And obviously then the, you know, the uncertainty factors would come into play there, but it really is dependent on the regulatory context. It's usually not 1 to 1. Usually people are looking for a higher degree of conservatism in their risk assessment.
Okay, here's another question from one of the participants. Have you used RISK21 principles for PFAS in drinking water assessment?
Not directly yet, no. I think there were some people that were interested in exploring how it might be used, but we haven't tried it. But if someone would be interested in working on a case example, I think that would be very interesting.
Okay, well, I'm sure they could contact you. Could you please share any examples of regulators, EPA, FDA, Health Canada, et cetera, that have accepted risk assessment, RISK21 frameworks for risk assessments?
Acceptance is a tricky word, but we've had very strong partnerships, as you saw on our advisory board, with several of the regulatory groups. I can just give a couple examples. I know one of the people who's working on a case example is that within Health Canada, we've been working very closely with PMRA on some ideas. We did a training with PMRA up there. Again, I think a lot of it is very interested in how it might be used. The question of acceptance is a bit relative. But we've been working with them very, very closely on some ideas. One of the water case examples is happening within a government agency as a potential way to help them prioritize for further assessment. That's happening. Within EPA, for example, there was an SAP just a week and a half ago, and I know the registrant was presenting this as RISK21 framework as a way to kind of illustrate how they move forward with that. I think it's really more of case by case. So this isn't something, and again, it's a very flexible, pragmatic framework where in general the approach is, it's pretty flexible, but we have seen a lot of interest from the regulatory community. I haven't seen, published risk assessments with these plots in there yet, but yeah, I don't know. We've had the other pieces with these outreach meetings. One thing I can say definitively is that the Chinese Food Safety Authority, the government agency in China that regulates food safety, they've implemented this approach nationwide for their food safety risk assessments. So that is something that's very direct. And also we've had outreach sessions where our government colleagues and regulatory colleagues have had us present and do these outreach workshop training courses with them. So lots of interest. I think a lot of it is just having robust examples that really illustrate directly within the context of use where they would apply it, how it would be useful. Long answer to the question, but I think lots of interest, and I think there'll be some more examples coming out in the coming year.
Okay, thank you. So could this approach be used to modify or refine import tolerances from various countries?
I think if you're talking, have to try it out. I mean, I think again, it's if you're approaching it from a risk-based perspective, and you're identifying, say you had, for example, an import tolerance, and you're able to compare it to known exposure information, or you have additional toxicity information and you want to demonstrate level of safety. I haven't tried it, but I don't really necessarily see why you couldn't give it a whirl and see what, again, a lot of it is how are you effectively communicating how that import tolerance was set, for example, on what pieces of information, and sort of what degree of conservatism is inherent in whatever that value is.
Okay, and one last one, unless some others come in. Have you seen this approach work better with certain classes of chemicals versus others, pesticides versus other types of chemicals, et cetera?
Not necessarily work better. I don't know that it actually has. It's really not specific to the chemical. We've had people try it out with like microbe growth, things like that within the food safety world. I just was involved and asked to present on this for how it might be applied in a case of microplastics. Haven't gotten into a lot of details on very, very specific chemicals. More of our examples, largely because of the people who've been involved in the last few years, have been focused in on pesticides, but it's very agnostic to the chemicals, so to speak. So would love to try it and maybe identify somewhere it absolutely may not work. That could be feasible. But I think it's flexible enough, and it's kind of I don't want to say generic, but it is relatively generic framework that you could use across various contexts. So haven't had any that it works necessarily better or worse for. It's more which contexts and uses have we tried and which types of chemicals.
Okay, well, that's the last question that was posed by our attendees. So on behalf of the Agro Division of the American Chemical Society and my personal thank you, we really appreciate you presenting today. It was very informative, and I'm sure the attendees were very appreciative as well. This webinar has been recorded, so it will be available at some point in the future for those who attended, and you can also share it with colleagues who you may feel would also benefit from it. So once again, thank you very much, Michelle, and that will end this webinar.
Thank you very much.